All right, guys, so what we're looking at here is, this is actually question number 6, not question number 4. I apologize for that, but this is from the 2019 exam. There's going to be a bunch of different ideas that get asked in this one, so let's just jump right in and look at the problem, okay? We've got 3 different functions. F, G, and H are twice differentiable, which just means you can take the derivative twice, no problem, no corners, no cusps. And it does say G of 2 and H of 2 are equal to 4, okay? So basically if I was looking at 2 different graphs, they would both have the same y value in x equals 2. We also have this line, y equals 4 plus 2/3 x minus 2 is the tangent line. The key to that is understanding this 2/3 right here is the slope of our tangent line at x equals 2. So what we could say technically is both g prime of 2 is equal to 2/3, and h prime of 2 is also equal to 2/3, and that will come in handy as we get a little bit further into the problem, okay? So given a lot of information here, but let's go ahead and take a look at what's going on. Okay, it says find h prime of 2, okay? So h prime of 2, we actually know that one already because we just talked about it. When we take the derivative and we plug in 2, we get 2/3. So that's it for letter A. That one was pretty easy. Letter B says we've got this function 3x to the third times h of x, and I want to find a prime of x and then find a prime of 2. Well, in order to take the derivative of this, we're going to have to use the product rule. So I'm going to have to say first times the derivative of the second plus the second function times the derivative of the first. So there's my derivative, then I want to plug in 2. So everywhere I see an x, I'm going to plug in 2. So I get 2 to the third times h prime of 2 plus h of 2 times 9 times 2 squared. Well, we found that h prime of 2, we just barely found it, is 2/3, so I'm going to put 2/3 in right there. And then h of 2, it tells us in the problem, that is 4. So I've got, and really I can leave my answer like that besides all of this stuff. So I have 2 to the third times 3, added those together. If you add those together, if you take the time to add them, you do get 160. So far so good, this problem's not that bad. Letter C says the function h satisfies h of x equals x squared minus 4 for when x does not equal 2. It is known as the limit as h approaches 2 of h of x can be evaluated using L'Hopital's rule. Okay, use the limit as x approaches 2 for h of x to find f of 2 minus f prime and f prime of 2 and show the work that leads to your answers. Well, the key here is that L'Hopital's rule is going to work. Without that, this problem is almost impossible. What that means is when I plug 0 in to both of these, or when I plug 2 into both of these, my limit as x approaches 2, I'm going to get 0 on top and bottom. That means that the bottom has to equal 0, okay? Which I know it's kind of weird. You're like, what? But that has to equal 0. I want to know what f of 2 is. So what I want to know f of 2 here, okay? That is to the third power. That's going to equal 1. So when I think about this, I say, all right, I just added the 1 over. If I cube root both sides, I get that f of 2 is equal to 1. Okay? Now it also says that it can be evaluated using L'Hopital's rule, which means if I take the derivative, so I'm going to take just the derivative of the bottom. It's the only part that I care about. I'm going to get 3 times f of x, and that is squared, and then I'm going to multiply that by f prime of x. Knowing that I know that the derivative, that is, take the derivative of the top as well, so I get 2x using L'Hopital's rule. I know that that is equal to 4, okay? Because I know that the function value, that the limit, since the limit exists, is going to equal this right here when I plug in 2. So I'm going to take 2, and I'm going to plug it in everywhere here. So I've got 2 times 2 over 3 times f of 2 squared times f prime of 2. Well, I know f of 2 is 1, so I've got 2 times 2 is 4 over 3 times 1 times f prime of 2 is equal to 4. So what I have here is 4/3 is equal to, if I multiply f prime of 2 over, I get 4 times f prime of 2. I divide by 4, and I get 1/3, so f prime of 2 is equal to 1/3. Now, I'm not going to lie, that is one of the harder problems that I have ever seen on the actual AP exam. Like, there's a lot going on here that you really have to understand in order to get the points. That one was rough, okay? I'm not going to say that one wasn't rough. That one was actually very, very difficult the entire time. So if you didn't understand that, don't get too frustrated, especially on letter D. Okay, so it says, it is known that g of x is less than h of x for between 1 and 3. And then it says, let k be a function satisfying g of x is less than k of x is less than h of x for between 1 and 3. Is k continuous at x equals 2? Well, the key here is understanding that the derivative exists at x equals 2 as well. For those two functions, for both g of x and h of x. I know that the derivative, so the derivative for both of those functions is equal to 2/3. Okay? It also says that g of x is above h of x. So it's like g of x is right there, h of x is right here between those two, and they meet at this point, and they are continuous, and here's the important part, they're also differentiable at that point at x equals 2. Well, if I'm going to draw another function that stays between those two the entire time, then what happens at x equals 2 is, and it can't be true everywhere else, but at x equals 2, because those two functions meet and they're both differentiable at that point, that means that the function is also continuous at that point. There's no way that those two things meet, and this statement right here is true. It's what's called the sandwich theorem, or the squeeze theorem, is why that happens, but hopefully that makes sense on that problem. So the answer is yes, it is continuous. So although this problem was really, really difficult, because it was actually only worth 1 point, so that one wasn't that bad. But I felt like the first part of this problem, A and B, were really easy. C was really rough. D was pretty tough too. Hopefully all of that kind of made sense.